So in this question, we're trying to figure out how long it takes for the heat to leave the styrofoam cooler. So if we just do a quick little picture, right? So I've got my cooler here. I've got my water and my ice cubes floating around in here. Just some information they tell us. They tell us that the length of the side is 1 meter. Okay. And they also tell us that the thickness of the wall is 15 millimeters, which we should convert to meters, which is 0.105 meters, because all of our units will be needed in meters. So this is the situation that we're doing. And important thing to tell us is that there's no heat lost here. All right. So all we have to worry about are the 5 other sides. So we got, if you think about a cube is 6-sided, right? That means that the only side that does not lose heat would be in the bottom of it. All right. So we were going to use that conduction current equation, or the formula chart from UT says that it's called the thermal conductivity equation. So we have two main parts to this equation. One is the Q, and the other is the H. So the Q, if we're looking at melting ice, will be the MLF formula, right, the latent heat of fusion. And then the H will be the other version of this, of thermal conductivity, which is H equals Ka TH minus TC over L. Okay, so those are the two pieces of information that we need to get to be able to figure out how long this will take. All right, so first let's figure out how much heat it will be added to the ice. Okay, so we got Q equals, and they tell us that there are 2 kilograms of ice, and that the latent heat of vaporization of ice is 334. So that tells us that essentially the ice is going to lose 668 kilojoules. Okay, which we need to convert to joules, because in the other equation, in the H equation, it's in joules. Okay, now we go over to the thermal conductivity equation. So we get H equals K, which is 0.033, and that's a known value for styrofoam. The area is 1 square meter. And then we just do our temperature. So it tells us that it's 40 degrees outside. The ice is 270 degrees inside. Right? They tell you that it's 40 degrees outside, and that the ice, or the temperature inside the cooler, is 0 degrees. These you do have to convert. This is not necessarily a temperature difference, because it's a hot temperature and cold temperature. In the long run, yes, it is a delta H, but be careful with this. You'll want to convert, because maybe you need to solve for the cold temperature, or you may need to solve for the hot temperature. And we're divided by the thickness of the walls, which is 0.015. So this tells us that the heat, or the thermal conductivity, is 8.8 watts. This is it's a unit of power, if you want to say it that way. Or not power, but yeah, power. So that's joules per second. But this is not the one that we're going to use in the equation, because that's through one side. And if we want to find the total, we have to multiply this number by 5 to tell us how much heat is lost completely from the water, or how much loss is joules per second, heat per second. And now we can go back to our Q equals H delta T formula and solve this for delta T. Now this delta T is temperature, and so we're going to do Q over H. So 668,000 joules divided by 44 watts, which is going to give us 15,181 seconds. And again, we'll convert to minutes and hours, because we don't know what question or quizzes and tests are going to ask for. So that's 253 minutes, which is approximately 4.2 hours. So either one of these is the correct answer. You just got to figure out how much, or what unit that quest or your homework is looking for.